Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patil, delivered lecture series on derivative. Right now we are going with the implicit function. Implicit function. We are going with the number of functions which are present in the form of y is equal to f of x. Y is equal to f of x, inside which y is given in the form of x. Y is given in the form of variable x. That means y is only or solely represent in the form of variable x. And therefore, when what you can say, if variable y is represented in the form of x, that means one variable is represented in the form of another only one variable. At that time, this function is called as an explicit function is there. Right now, if some equations consist x and y variables, that means two variables, but x is not solely or not explicitly represented in the form of y, or y is not explicitly represented in the form of x. That means you cannot separate or bifurcate the variable x and y from each other. That means if we are taking y common or x common and we can transfer it to the left side, at that time it is not completely bifurcate that x and y variables. That means when we take the y variable on the left hand side and the remaining variable on the right hand side, at that time there will be only variable x is not possible. At that time, that function is called as an implicit function. That function is called as an implicit function. For example, we have to take the consideration of ax square plus 2hxy plus by square is equal to 0. This expression, in that expression, if you are going with taking y only at the left hand side and remaining terms on the right hand side, for this purpose, first of all, we have to transfer this to the right hand side. At that time, you will get the 2hxy plus by square is equal to minus ax square. And if we have to taking the y is common from here, at that time 2hx plus by is equal to minus ax square. And we can transfer this term to the right hand side. You will get the y is equal to minus ax square and divided by 2hx plus by. Here we can represent y in the form of only x? No. Here y is represented in the combination of x and y. If we have to taking the x also common and we can represent x in the form of y, at that time you have to get the same situation where x and y are not separated from each other. At that time, that type of function is called as, or that type of equation is called as an implicit function. We have to carry out the derivatives of the explicit function, inside which y is taking only in the left hand side and function it is represented in the form of x only. At that time, you can perform the explicit function derivative. Right now we are going with the implicit function derivative. For this purpose, we have to carry out the procedure, and the procedure of derivative of implicit function. First of all, we have to take the derivative of equation as it is. We have to taking the derivative as it is, which is taking in the explicit function. That means function in the form of y is equal to f of x. At that time, you have to taking the derivative of that y with respect to x. That means dy by dx is equal to something. We have to carry out the derivative of that is nothing but f dash x is there. Taking the derivative of equation as it is, which is taken for the explicit function. Whenever there is a y, if the function consists y or the term consists y, then y is there, then we take the derivative of y is as a dy by dx is there. If y raised to n is inside the equation, at that time, first of all, we have to carry out the derivative like x raised to n, d dx of x raised to n. d dx of x raised to n is nothing but n into x raised to n minus 1. Similarly, y raised to n having the derivative n into y raised to n minus 1. And then again we have to take the derivative of y is nothing but dy by dx. Then collect all terms containing dy by dx on LHS. That means those terms which are containing the dy by dx, which are transferred to the left hand side, and take dy by dx common from the terms in a in a LHS. That means those terms which containing dy by dx are transferred to the left hand side, and we have to take the dy by dx as a common and transfer remaining thing on LHS to the RHS, except dy by dx. That means dy by dx is not transferred to the RHS. Only after taking the dy by dx as a common, remaining term is transferred to the right hand side. You will get the derivative of that function with respect to x is there. For example, we have to consider here, that means you have to get the consideration of dy by dx is equal to, we have to find the derivative of that function. That means dy by dx, we have to find out the dy by dx if x raised to 5 plus 3x square y plus 5xy cube minus y raised to 4 is equal to xy cube minus 3y square plus 5, inside which we have to perform any type of operation. We cannot separate the x and y from each other. That means this equation is nothing but an implicit equation, or it is an implicit function. Then we have to carry out the procedure as it is. We have to taking the derivative of normal function. For this purpose, first of all, we have x raised to 5 plus 3x square y plus 5xy cube minus y raised to 4 is equal to x y cube minus 3y square plus 5, written as it is. And then we have to taking the derivative, derivative of function, derivative on both side with respect to x is here. And therefore you have to get the consideration, each term have to taking the derivatives here, and therefore d dx of x raised to 5, d dx of x raised to 5, then plus d dx of 3x square y plus d dx of 5xy cube minus d dx of let us to consider here y cube minus d dx of y raised to 4 is equal to d dx of x into y cube minus d dx of 3y square plus d dx of 5 is here. That means we have to take the derivative of each term here, and here x raised to 5, that means derivative of x raised to n is nothing but a n into x raised to n minus 1, and therefore the derivative of x raised to 5 is 5 into x raised to 4 is here, plus 3 is a constant and taking outside from the derivative, and here we have to get the d dx of x square into y plus, once again 5 is a common, taking outside 5 into d dx of x into y cube minus d dx of y raised to 4 is equal to d dx of x into y cube minus 3 into d dx of, that means 3 is a constant, taking outside from the derivative, y square plus derivative of 5 is nothing but a 0 is here, because constant having derivative 0. Now 5x raised to 4 plus 3 into bracket, because here two functions are multiply each other, that means you have to going with a multiplication rule, and therefore you will get the consideration of x square as it is into derivative of y. We know that according to procedure, derivative of y is nothing but a dy by dx is here, dy by dx plus y is taking as it is, and derivative of x square is nothing but a 2x is here, plus 5 inside the bracket. Once again here two functions are multiply each other, that means first function is taking as it is, and derivative of y cube, it is a taken like a y raised to n, that means n is equal to 3, and therefore you will get the 3 into y square into dy by dx plus y cube is taken as it is, and derivative of x is equal to 1 minus y raised to 4. Then once again we have to take the derivative y raised to n. That means n into y raised to n minus 1 into dy by dx. That means 4 into y raised to 3 into dy by dx is equal to, once again here multiplication is there, and therefore first function is taken as it is, and derivative of x cube is nothing but a 3y square into dy by dx minus 3 into derivative of y square is taken similar as a y raised to n, and therefore you will get the 2 into y raised to 1 into dy by dx, and 0 is cancelled to there, and right now we have to get the consideration 5x raised to 4 plus 3 is multiplied to that both terms, and therefore 3x square dy by dx plus 3 into 2, that means 6xy, x and y is here, then plus 5 into 3 15x y square into dy by dx plus 5 into that y cube, 5 into y cube minus 4y cube into dy by dx is equal to 3x y square into dy by dx minus 3 into 2, that means 6y into dy by dx. That means we have to taking the derivative of each term as that of taking as a normal equation, that means explicit function as it is. Then next step is related to that one. We have to collect the terms containing dy by dx on LHS. That means those terms which have containing the dy by dx are transferred to the left hand side, and those terms which does not containing the dy by dx are transferred to the right hand side, and therefore this term does not contain the dy by dx, then it is transferred to the right hand side. This term containing dy by dx, then it is remain as it is in the left hand side, therefore 3x square dy by dx plus this term this term containing does not containing the dy by dx, then this term also transferred to the right hand side. This term containing the dy by dx, therefore it is placed as it is, that means dy by dx. Then this term does not containing, and this term containing the dy by dx, then 4y cube into dy by dx. This term containing the dy by dx, but it is present in the right hand side, and therefore it is transferred to the left hand side. You will get the minus 3xy square into dy by dx. Then this term containing dy by dx, but it is present on the right hand side, therefore it is transferred to the left hand side, that means plus 6y dy by dx is equal to those terms which does not containing the dy by dx, which are present on the left hand side, is nothing but a 5x raised to 4, 6xy, then 5y cube. Those are the transferred to the right hand side. That means we will get the 5x raised to 4 plus then it is a transfer to the right hand side, then it is becomes a minus 5x raised to 4 minus 6xy, and this minus 5y cube is here, 5y cube is here. And right now we have to taking the dy by dx as a common from the each term which is present on the left hand side is here, and therefore you will get the dy by dx, and inside the bracket 3x square plus 15xy square minus 4y cube minus 3xy square plus 6y inside the bracket, and therefore you will get the minus is taking from there, you will get the minus inside the bracket 5x raised to 4 plus 6xy minus plus 5y cube is here. And right now the divide by dx, last step is nothing but the remaining term which are on LHS is transferred to the RHS except dy by dx. That means dy by dx remains as it is, and this term is transferred to the right hand side. That means it is a multiply here, then it is a divided here, therefore you will get the dy by dx is equal to minus inside the bracket 5x raised to 4 plus 6xy plus 5y cube divide by 3 3x square plus 15xy square minus 4y cube minus 3xy square plus 6y is here, and this is your final result related to that implicit function. You will get the implicit. What is the implicit function? That means explicit function is containing that one variable is represented in another variable, but in implicit function we can't separate the two variables from each other. That means x and y are not separated from each other. At that time you can follow that procedure. That means you take the derivative. If there is a y, then we take the derivative dy by dx. Y raised to n is there, then we take the derivative as a n into y raised to n minus 1 into dy by dx. Collect all terms of dy by dx on the LHS and taking the dy by dx as a common, and remaining term is transferred to the RHS. You will get the final result related to your function. If you like that video, please subscribe my channel and press on bell icon to get the next notification related to lecture series of the derivatives or differentiation. Thank you.